God willing, and we shall return.
We are back with more Artemis podcast, the third episode. We got a big list of things to go over because we forgot to do it last time, but on our list we have the fiscal year 2021 budget request, the State of NASA address, the modal testing of the SLS core stage, the green run and what's next for the test, the Orion completion of thermal vacuum testing, rovers and capstone for the Artemis program, Artemis Day 2, and Mars sample return. We'll welcome in our panel here. We have Mr. Fu.
Hey, how's it going?
We have Freddie.
G'day.
And David Willis.
Yo, 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 what's up?
And over the course of the podcast, we might have more people coming on here. So, what's first to discuss?
Well, I think we should maybe talk about the fact that they just totally hit SLS with a hammer. Like an actual hammer. That's pretty interesting.
Yeah, we all know what happened the last time. They hit a rock with a hammer.
Ooh, don't say that. We don't want that to happen.
Yeah, so modal testing. I guess it happened faster than expected. That's a plus for the SLS program. Yep. Green Run. The next thing on their list is they're going to be testing their systems. They're going to be powering them on. So I guess they're going to be doing that one by one, and at the same time, they're going to be putting in those LH2 feed lines, which they should have done by next month. Actually, it's kind of all coming together. I know there was an insider that we had, and he was saying late July to early August time frame. But I mean, there's no guarantees right now with Green Run because it's kind of up in the air right now.
Yeah.
They didn't have a schedule in the last ESD update, and I'm not sure if they will have a new one. Hopefully they'll have a new one in the new ESD update in March. I didn't really see the state of NASA. Has anyone seen it yet?
The state of NASA, I saw it.
Yeah, what was it all about?
Well, can you pull up the picture of Jim Bridenstine standing in front of the engines?
Yeah,
I got something interesting to say about that. Okay, so the engine to his right, our left, the one that's horizontal, that engine will power Artemis 2 into space, the first crewed mission back to the moon since 1972. And then the engine on his left, our right, that's vertical, that engine will fly on Artemis 3 to go to the moon and land.
Yeah, they only have 2 of the engines ready for Artemis 2 though.
Well, actually, I think only two of them have flown on shuttle missions, but 2 of them, I think they were finished, but never flew on shuttles.
Mm-hmm.
If I remember correctly. And so for Artemis 2, this will be their first flight, which is curious to me because I would think that you would want the most reliable engines for your first crewed mission to the moon, and use engines that have already flown.
You'd think that, but somehow that doesn't happen.
But Artemis 2 will feature 2 new RS-25 engines that have never flown.
Yeah, that sounds like a Artemis 1 thing they should have done.
Well, I think you were right. They didn't because they never finished building that. The shuttle program was canceled. Although they existed as engines, they weren't ever completed, and so they were lagging behind all the other engines. And so this is going to be their first flight, just so that SLS's core stage could be done on time. Well, on time as you can get when talking about SLS.
Has a flight-ready RS-25 ever had a failure?
I think there was one time where the shuttle did have to do an abort to orbit because of a problem with an RS-25 engine, but I'm not sure which one it was. I know
Oh,
it
yeah?
definitely had. There was definitely an abort to orbit, but I don't remember if the problem was the RS-25 engine.
I think it was STS-93, was it?
STS-93, I think, isn't that the one with John Glenn on it? No, that was STS-95. Hold on.
Yeah, they recently talked about like 20 years, the 20-year anniversary of it, like this summer.
This occurred on mission STF-51F, which continued despite the abort to a lower orbit. So yeah, it was STS-51F.
What was the actual? Did they specify what the failure was on the RS-25?
It was the 8th flight of Challenger, actually.
Wow.
And let's see,
Could've been that.
let's see, what was the cause of the problem? Okay, Challenger experienced multiple sensor failings in its RS-25 engines and had to perform an abort to orbit. So it wasn't the engines themselves; it was the sensors in the engines that had the problems.
Wait, could you explain what an abort to orbit is?
So, when the shuttle is going to orbit, it has a certain amount. The shuttle plus the external tank actually weighs more than the thrust provided by just the 3 RS-25s. So when it's going up, it burns off a lot of the fuel, and it can get to its desired orbit in time. Now, if you cut one of those engines off, it's going to be a lot more difficult to get to your desired orbit. But if you're already going fast enough, you may not be able to get to your desired orbit, but you may still be able to get to orbit, and then from orbit come back down at a later date. What Starliner did was an abort to orbit in some sense.
Oh yeah.
Where it didn't get into a spacecraft doesn't get into its desired orbit, but instead of re-entering, it will go into a lower orbit and stay there until a designated time for it to come back. And that's an abort to orbit.
And that's in contrast if you have a ballistic abort, like what happened with the Soyuz that had to abort. So they obviously couldn't get to orbit, but they could come back down in some semblance of a safe manner.
Yeah, if you're gonna do an abort to orbit, you have to already be like going pretty fast. Like
you want probably want to be in about 50 kilometers up if you're gonna do. Like,
the thing is,
it's not just altitude; it's also your lateral velocity.
Yeah, I was about to say height isn't really what you're looking for an abort to orbit. You're looking for how fast you're going, because your speed is like, imagine you're throwing like a baseball, and you throw it and it goes up in a little arc and then hits the ground. Well, if you throw it fast enough, it's eventually going to get to say halfway around the planet if you throw it fast enough. Now, if the arc that you're going to follow is going to take you around halfway around the planet, you're probably going fast enough where you could increase your speed a little and get into a lower. I don't know if that made sense, but I tried.
It made sense. I just never heard that term before. That's why I just asked.
Right. Actually, it's interesting. The abort is not just when the rocket explodes and the solid motors fire to take your capsule away. An abort is a bunch of things, and all of them are designed to make sure that the crew gets away from the mission safely.
Yeah, it's really any deviation from the original scheduled flight plan.
For example, Apollo 10 did an abort. When they were simulating the Apollo 11 flight, one of the mission goals was to simulate an abort. And what they did was they descended across where Apollo 11 was supposed to land, and then before they actually landed, they pulled the abort switch on the LEM to shut off the descent engine and fire the ascent engine and get back into orbit. And so that would have been an abort to orbit using the LEM.
Like, could you also say like Apollo 13 was also an abort? Like, because
Apollo 13 was
sort of
aborted the mission. So yes, it wasn't abort. It was an abort of mission.
Yeah.
And they almost had a threshold crossed during the ascent from Apollo 13, where their central F1 engine was not outputting the amount of thrust they wanted, and they almost reached the threshold of having to abort there.
Wait,
Yeah.
wasn't it the J2 engine, the center J2 engine shut down?
It might have been. It was one of the central.
It was on the
engines.
second.
Because
Yeah,
I think
second stage. Yeah, you're right.
it was the J2. I have a lot of experience. I know just how badly that would have gone. I've played Kerbal so many times. I know just how bad it is to lose a J2 engine.
I lose my entire spacecraft in Kerbal Space Program half the time. Just trying to get to orbit.
Yeah, but anyway, back to aborts. Like,
yeah,
the space shuttle had, most people think the space shuttle couldn't abort at all, which isn't true entirely. The only thing the space shuttle could not do was it did not have a mechanical abort system, and a mechanical.
I know.
Well, beyond the first like 2 flights.
Well, it's debatable whether you can consider ejection seats a mechanical abort. I mean, I guess you.
I mean, you're physically separating the intended payload from the spacecraft. I consider that mechanical.
Yeah, I guess that would be a mechanical abort. But in general, the shuttle did not have a mechanical abort, but the SLS does, and that's the abort tower.
Yeah.
But the shuttle still had plenty of abort modes, what?
I know it could like one of its abort modes was it could separate from the main tank with its SRB still attached to it. Glide down. Was that like?
Well,
possible?
okay, so the shuttle actually, out of all manned space ascent vehicles, the shuttle, though it had abort systems at different points during its flight plan, it had the largest gap of really a non-survivable scenario from an abort. So if you were at the point where the SRBs were still firing and you had to separate the main shuttle from the main launch portion of the rocket, it was never actually, technically they could detach, it was never actually expected that they could survive, because the shuttle is not meant to fly through the air at that speed while being aerodynamically sound. It just wasn't really feasible. So they could try it, but none of the engineers actually thought it would happen.
And another thing is the SRB exhaust plume would hit the thermal blanket, the white thermal blankets, and all the other stuff that's on top of the shuttle. Instead, now it could probably withstand the heat from the heat shield, but with all that SRB like flames and stuff hitting the top of the shuttle, it probably wouldn't fare too well for the crew inside of that. Because once you separate that shuttle, the SRBs are going to have a much higher thrust to weight ratio, and they're going to speed past you, even if they're attached to the external tank, because they just dropped the 60+ ton orbiter.
Yeah, and the aerodynamic properties of the shuttle at the orientation that it would have while separating from the tanks would likely tear it apart. And because the shuttle could have strong forces against it, but it had to be at a very specific angle, and it wasn't at the optimum angle when it would separate from the main tank.
Because even if the shuttle's going at a little bit of an angle, once it separates from that tank, if it pitches backwards just a little bit, it's gonna flip and rip itself to pieces because of the drag.
Yeah, it wasn't designed to have that much aerodynamic pressure against it at any time during that point.
That being said, once the SRBs shut off, there were several abort modes that could go down. There were 2 main ones. You had the RTLS, the return to launch site, where the shuttle would peel off from the external tank and then glide back to the runway at the KSC. And then there was the transatlantic abort, where on the coast of Africa, there is a runway that NASA owns for if the shuttle could not do an RTLS, but it still had like an engine that was operating, it could fire that engine just long enough so that it could get to a place where it could ditch the tank and then glide down to the runway in Africa. And that was the transatlantic abort. So that you had RTLS, the transatlantic abort, and then you had the abort to orbit. And those were the 3 main aborts that the space shuttle had. And then also there was the mission abort, where the engines would it would get down, and then it would cut the countdown and abort the mission. So that was an abort before the mission even started. And that happened quite a bit on the shuttles.
Next on the list, we have Orion completion of testing, thermal vacuum testing at Plumbrook.
And yeah, it's about halfway done with its thermal testing at Plumbrook. I mean, no, not it's done with thermal testing, but it's halfway done with its entire testing.
Yeah, so when is it scheduled to get back to the KSC?
Well, the thing is, it will finish testing before March 11th, and I know that because March 11th is the NASA social where they're gonna take people out to see this in Plumbrook, and so obviously if it's still in testing, they're not gonna have the social on the 11th because nobody will get to see it. So I assume it will be done testing before March 11th, and then after that, it shouldn't take but maybe a week or two to get to the KSC based on delays and flights and all that good stuff. And so we should see Orion return to the KSC pretty shortly.
According to say within like next few months.
It should be at the KSC before SLS Green Run.
What are you guys talking about?
The Orion.
Yeah, like the massive crew capsule that's sitting in Plumbrook right now.
And it's massive. It not only, most people don't realize just how big this capsule is. Not only does it have a physical restroom that is like a restroom, underneath all the seats is an entire radiation shelter for the crew to go in. This thing is massive. There's a big radiation shelter underneath the seats, and then next to that radiation shelter is a full-on like a bathroom with a curtain that you can move and close for your own privacy. But it's like if you took the cockpit of a space shuttle and squished it down so everything was right next to each other.
I'm just gonna mute my mic for a sec.
Wow, that's amazing how they managed to cram all that stuff in.
But the thing is, Apollo was actually a lot bigger than people thought. It seems small because it had these massive seats and this big old clunky electronics and thing. But behind that, there's actually a space where if you could squeeze out of the seats and go behind them, there's a space that you could stand up and move around in. So it was actually pretty big as well. But that being said, Orion will feel 10 times bigger than Apollo, because not only is the computer control board much smaller due to the miniaturization of electronics, the seats are much smaller and will all fold into the ground of the spacecraft, so that you have this big wide open space.
Wow.
It's fairly large.
They really went all out on this. You can fold the seats.
It can fit up to 6 people, but will only fly with 4 due to life
support.
Due to life support at the moon.
What I'm curious to see is, like, I haven't actually seen a good representation of what the open air volume is inside Orion, because I know one of the big problems that they ran into with Skylab was, yeah, it's cool to have all this big open space, but when you're in 0G, like, you kind of don't want space. You need things to grab onto so you can maneuver and move around in the capsule.
Well, I think Orion, you cannot stand, if I'm correct, you cannot stand from the floor to the ceiling straight up and down. I don't think it's big enough.
Okay, on screen right here is the budget request.
And so this is that 3 billion.
Is this PDF available? Did anyone post it in the?
It's in Mikeless People. So Woot posted it.
I think there's a total of 3 billion that the president wants allocated to the lunar lander specifically.
Wow.
I think that's all the money he wants NASA to get, because NASA's budget is already 22 billion and it only increases to 25 billion. So I think the only change really is the 3 billion for the lander.
Oh, so I didn't notice this, but it says
what I'm concerned about is this lander. It isn't gonna be a cheap spacecraft. I mean, like, it's going to be a spacecraft. Like the spacecraft, like, it's gonna be like Dragon and Starliner, it's going to cost billions of dollars, and I'm not sure $4 billion is really, or 3.6 billion is really enough to make that work.
It's not going to cover it, like with all the.
Let's just say it's definitely not going to work if they give the contract to Boeing. It's not going to work.
Oh.
Because here's the thing: Boeing has no hardware, they have no experience, and they have no way to build it because they're building 2 spacecraft already. They're building the SLS and they're building Starliner. So they're already occupied. Please do not give them this lander. Please do not give them.
What about JPL? What about JPL?
Who all is in this potential contract?
Well, the biggest player, other than Boeing, is the National Lander Team, or the National Team, or whatever it is. And
it's like a couple different contractors working together, or what?
It's a bunch of contractors working together on their own accords. Normally, NASA, what they would do is they would pick contractors to build different parts of a rocket. But these contractors have all come together on their own without NASA telling them to, and say, we will work together to build this lander for you, NASA. So what they're going to do...
I think that's actually...
It is.
That's like cheaper.
It would be way cheaper because NASA doesn't have to pick anyone. They just say, okay, national team. And they've already got the contractors and what parts they're going to build. And the national team actually has hardware already. Technically
no rigmarole.
Because the descent stage is going to be built by Blue Origin, and they've already tested the engine for that. So, and then the ascent stage is going to be built by Lockheed Martin, and I'm so happy for them because they've been trying. It seems like every year they propose a lander, and like they clearly want to be a part of this. And so I'm glad that they finally have their lander for this.
Lockheed Martin just keeps getting thrown in the gutter.
I mean, they have Orion, but they so badly want a lander. They like. Have you seen how many lander proposals they've made CGI videos for? Like they want this. I'm happy for them. They're gonna get the ascent stage, and then a legacy player in the moon landing business, Northrop Grumman, is actually going to be building the transfer stage from low lunar orbit to the gateway. And Northrop Grumman, as we all know, built the entire lunar module last time, so they've got experience under their belts. And then there's one more. I think it was Draper. Draper is building the electronics and stuff. And so all four of them together, plus I think some few others that have joined recently, are going to be build what is called the National Lander. And I don't know if that's going to be the name they stick with, but they are looking right now to be the biggest player in this landing game. And then SpaceX has their proposal. I don't know what they're going to do. I hope it isn't Starship, because that's not going to be ready anytime soon.
Yeah, okay.
SpaceX making a lander.
So that team that you talk about, all these different entities, most of which have some type of experience with landers or with actually getting to orbit or whatnot. My big concern
well, let's not say orbit, because there's a certain someone who has never been to orbit.
Right, which is exactly what I was about to say. So I think the big elephant in the room is who they picked as like the main powerhouse of this lander is not a tested system or from a tested company that has done stuff in space. And I respect a lot of what Blue Origin is doing, but I question these companies that are saying, well, the main central powerhouse of our launch platform or our lander is going to be Blue Origin. I think that's pretty ridiculous, honestly.
We've got two choices here. We've got this one, the national team, that actually has experience and has
mostly experience.
It's got a bunch of
one entity, which
it's good experience.
The single most pivotal point is going to be the propulsion, and they are extremely untested.
They've already tested the B7 engine
in atmosphere. Yes, that's true.
In atmosphere, that is
never
true.
gone anywhere other than here. That's my point. Everyone else experienced.
Name what engine is going to be the descent engine on Boeing's lander. Exactly. You can't even name it. They don't even have that.
That's not what I'm saying.
Like, I'm just saying, they've already, like, Blue Origin, they
have done one thing, which is hop a bunch of times.
But they've done that's the biggest part about landing on the moon is being able to retropropulsively land.
No, that's thrust
If anyone,
vectoring.
I mean, the LEM wouldn't have gotten on the moon if it couldn't propulsively land.
No, I know. That's not what I'm saying. I think you're misunderstanding. I'm saying I think backing Blue Origin as the main entity for your descent stage or whatever for your lander is a huge question mark. I would ask them to prove a lot more than just launching the same. What is it? New Shepard? What's their small one they keep popping?
The new Shepard. But that's the thing.
Which isn't even the system that they're planning to use.
But hold on just a second, because that's what Blue Origin is doing two separate things. They're doing the Blue Moon lander for the commercial lunar payload services, and then they're also doing the national team, which will use the Blue Moon as the descent stage. Now the thing about the Blue Moon is that it will first fly and land on the moon with the CLIPS program, and then they'll do that a couple times and test out the systems and stuff. And then once that's proven, they will put that underneath the Lockheed Martin ascent stage and above the Northrop Grumman transfer stage, and then they'll use that to land on the moon. This will not be an unproven system by the time it takes crew to the moon. The only question is, will it be ready by 2024?
Yeah, and that's exactly what I'm saying. Is I'm not saying that it's going to be untested when they actually employ it. I'm just saying, like, how come no one has asked Blue Origin to do anything for any of their other missions, period? Blue Origin is kind of like somehow slipping through the cracks and being contracted to do all these different things without actually being tested. It's surprising to me that Blue Origin hasn't done anything aside from their hopping program. That's it.
Well, I mean, you've got to also remember who's the CEO of Blue Origin. That's right, the richest man in the world. He can do anything he wants if he has enough money.
Exactly. Which is why I'm questioning it.
Well, I mean, look, it's either this or the flaming garbage fire of thermite that is Boeing right now. Like,
Boeing's problem is they need to like hire new software engineers. Every single issue they've had over the last 3 years has been software. So like Boeing's aerospace capacity is fine. They have a lot of experience, and their engineering is like, there's no issue with their engineering and their employment of stuff aside from software. Just fire everyone who writes your code.
It's not that simple. Boeing is we've gotten accustomed to Boeing being a space company. They're not. Let's be real. They're an airplane company who makes space hardware.
That's not true. That's not
true.
Listen,
hold on, listen. They've got most of their engineers building planes, and then they have more.
Engineering is not the problem.
Listen.
Keep saying listen. It's still not true.
You're not hearing me out. They have engineers working on their planes. They have engineers working on Starliner, and then they have a bunch of engineers working on the SLS. How did I forget that? They've got a massive workforce, but it's split up against all these programs. And now you're asking them to build a full lander. This is their proposal, an entire lander with their workforce that is currently spread around 3 projects, 2 of which are NASA projects. So if they build this lander, which they can definitely do it. I'm concerned about how fast they can do it, because that would be their 3rd in progress NASA project that they would have to be doing, and they'd be starting it now.